Just to introduce myself, I'm Jesse Trank. I'm an applications engineer with Mastercam CNC Software Inc. And I work in the manufacturing lab at our facility. We've currently got 5. We had 6 CNCs in there, ranging from a simple lathe up to, or CY-axis lathe, up to a mill turn, a couple 5-axis machines, and a 3-axis Haas. So we get to play around on those machines and prove out the software. And this is going to be a result of sharing some of the stuff that we find in there. So to start, this webinar, we're going to work up to multi-axis remachining using stock models. But first, I want to talk about stock models and kind of their typical use, what they were kind of first used for, and the rest of the stuff we're going to dig in is kind of an after effect of that, some after functionality. So some of the main typical use here is rest machining, right? And that's using the stock model to create these models that represent what stock is left from a prior operation, and then using that with a subsequent operation to reduce the amount of air cutting, keep the tool engaged in material as much as possible and trim the tool path to where there is material. Some other things that are very helpful with stock models that are kind of a side effect, and we're going to touch on them, are using them for initial stock. I'm going to show you this in a second. And then using them to show the material state in how your process is progressing, right? You can always see where you have material, where you don't, and it helps you make more intelligent programming decisions. And then lastly, we have a visualization, and you can use them for verification. So you can use these to seed your verify file, right? You can use these to create the initial stock for verify. But it's also a quick visualization inside of the Mastercam interface of where your stock is, and it can help you, as you program. So let's jump into Mastercam and kind of talk about some of these typical uses, or talk about the typical use of stock model. And I know I said using stock models as initial stock, and this is something I do all the time, right? I'll create a stock model right off the bat. And it's on a level, I have this initial stock model, right? So if I shut this stock model off, I have this as a model, a selectable solid model in my Mastercam file. But I really, really prefer to create a stock model based off of that model. And what I mean by that is in the parameters, I'll select model and go out and pick that model off that level. And I won't pick anything for source operations, right? And that gives me a piece of stock now in here that I can see really quickly and toggle on and off inside of my ops manager. So it's something that I have come to get accustomed to, and it's part of my workflow in Mastercam. Whether that works for you or not, that's something for you to decide, but it's something that you can use. And then as you progress through the model, you do some programming, you progress through your programming. You can keep track of where your part sits with respect to stock by using these stock models. So you see I have one operation stock model, another operation stock model. Each one of these operations is referencing that stock model that happened before to ensure that it's cutting the least amount of air. This is what we would refer to as using stock models for rest machining. Okay. The nice thing about what you can do with these in-process stock models is we can use them for verification, right? A lot of times I'll see customers or users they want to verify, they really want to only verify this operation 6, right? But instead they're going to choose all these options to launch verify and have to watch the first 5 minutes of verify run just to get to the point where they can see this third toolpath. So instead, what I suggest, you go up into your verify options. You can use your stock models. Let's see what that one's called. The one before that is called After Rough Op 2. I can pick that one. And now I can launch this verification. And besides just using that for verify, we can also use it to visualize, real quickly, just see where that where that stock exists in the part and in your process. Okay. Moving on. So now I want to touch on a few tricks that you can enhance the functionality of stock models, or a couple little things that just will make life easier when you're using stock models inside of Mastercam. One of those big things is tolerancing. This is something that people all too often look over, and they just stick with the default tolerances. And that's fine for a simplistic file, right? But when you start getting into something real complicated, really complex, a lot of different toolpaths, a lot of different stock models, your tolerancing with your stock models becomes very, very important. And I'm going to jump into Mastercam real quick to show you what I mean by that. So we're in a metric file here. You'll see that under the stock definition page, I have a tolerance associated with my initial stock shape tolerance, right? So I want to make sure that I'm not getting too crazy about how precise that initial stock needs to be modeled. In a metric file, I'm putting in something like 0.1 millimeters. For the source operations tab, I can also control the tolerance of the tool path that it's referencing, as well as the tool shape that is the tool that is being used in that path. Both of these tolerances should be as loose as you can get away with. In a lot of cases, if you're using a bigger tool or you're leaving 1 millimeter of stock on the part, do you need to see the exact amount of material that's left on there down to the 1/10 of a millimeter? Maybe not, right? Maybe I could come in here and put a tolerance in here that's more like 0.2 or 0.3 or even 0.5, and I'd still get a good enough result to use for rest machining. It all depends on the purpose you're trying to use those stock models for. Another thing that I really like that I really think enhances using stock models inside of Mastercam is the glass rendering capabilities of stock model. So I've gotten in the habit of using glass for stock models. Now, what does that do? If I go into my view tab and I turn on material display, that allows me to have a transparent view of the part. So I got a question here to give examples of tolerances in inches. In inches, it would be a similar scenario, right? If I had a 1/2 inch tool and I'm leaving 100 thousandths on the part, it's not important that I calculate that stock model out to 0.001 to a thou. That's overkill, right? I've been known in an inch file roughing with a 1/2 inch to leave a tolerance of 0.1 inches of 100 thousandths if I'm leaving more than 100 thousandths on the part for my initial roughing operations. You start getting into hard to machine materials, nickel alloys and stuff, where it's very critical that you don't overload the tool and you're using a small diameter tool. Well, you need to be much more precise with your stock models, because if you run into unexpected material there, you're going to have a broken tool. All right, so that's the glass functionality of the stock model. I really use that a lot. I encourage use of that. Same thing with this next stock model. So I can see the model behind it. Without glass turned on, I'm just seeing the block of model. I don't really know that there's a full-size pocket under there. But with material turned on, I can see that pocket and know that I have to go in there and machine it. It's a very subtle thing, but it can really help. One other thing that some people aren't aware of with stock models is that I can export them. So I can go into my mill toolpaths here and say stock model convert to PMesh. I can also do that underneath the toolpaths tab, convert to PMesh. So that's going to take that stock model and make it a selectable entity on the screen. Okay, so now I can take that and I can do a dynamic transform, right? If I want to use this in a different spot on my part, I can rotate this over to another plane on like the side of another tombstone or something, and then create another stock model that references this mesh as the initial stock. It's a very, very powerful thing with stock models. The one issue there is it is not associative. So if I make changes to the stock model, I would have to redo that. But it is a way to do things creatively with stock models and move them around. Okay. The other thing that not a lot of people know with stock models is that you can use surfaces to drive stock models. So if I go into my surfaces tab here and I just create a surface down on this entity right here. So I've got a surface. This could be on the part that you're actually machining, right? I can come in and create a stock model that references that surface. And this is where we're going to really leverage when we get into the multi-axis side of using stock models. So I can say for a model, I want to pick only surfaces. I'll pick this, right? And if I just leave it at that, I'm not going to get a lot out of it. But there's this additional offset field. So I could say, well, let's put another 10 millimeters of offset on this stock model. And what that's going to do, it turns a sheet body into a piece of stock. Now, I'm just showing you this. It doesn't look all that exciting right now. But when we get into the multi-axis side of things, that's going to be very, very powerful. Okay, so keep that in mind as we progress through this. I got a question. Can you add material to the stock model after a toolpath? Of course you can. You can do, if I've got this stock model halfway down through my ops manager, I can add additional offset to it. What that is going to give you is, if you had a really difficult to machine material, that could give you more of a safety zone when you're leading into the material. But it is going to give you more air cuts, right? Because you're telling the toolpath that there's stock where there actually isn't. So that was a good question, though. All right. Another thing I wanted to show is in the stock model, there is the stock compare utility. Okay. That allows you to go in. If I turn this on, that's going to color code the model based off the amount of stock that's left. And I can change the colors and change, the different heights of the stock and that sort of thing. But it's going to give me almost like the stock compare utility in Verify. I'm going to get a very similar result. If I jump back into my PowerPoint here, this image right here, that is going to be very similar to what you're going to see in your stock comparator. So you can see in the corners, I'm leaving, up to 5 millimeter, but on the part itself, it's somewhere between 1 and 1.5 millimeters, right? So it's just based off of your stock to leave and how it calculates. It's going to color code the model. Now, the last thing, the biggest trick here, and this is what we're going to be talking about mostly in this webinar, is getting the toolpath to focus in a certain area or trimming certain sections of the toolpath out by using stock models instead of the conventional means of something like a 2D containment boundary. All right, this can be very, very powerful. So let's go on here. So first, we're going to talk about it in the context of roughing, like an OptiRough toolpath, right? We're going to force that toolpath to go into these specific pockets without worrying about the rest of the part. It'll still be gouge checked against the entire part because we're selecting the whole part for surfaces, but it's only going to see stock in those pockets, and we're going to drive it that way. How we're going to do that is via solid plugs. We're going to put plugs inside those features. All right. And to do that, we're going to use model prep modify. All right. Then we'll create a stock model from those plugs, and then we'll drive the toolpath, trim the toolpath using the stock rest machining options against that stock model. So let's hop back into Mastercam here really quick. And let's see, let me shut that toolpath off. All right, so for roughing, when I said we were going to fill those gaps, let's go, we can do that with model prep. So model prep, modify feature, we have create body, remove, and create body. I'm going to use create body. With a triple click in a, I did it too many times. With a triple click in a feature, that's going to select that entire feature intelligently, right? Now I can say create body, I green check out. That's going to put a plug, a solid plug in that area. So let me shut off this the model, you see the plug that it created. All right, so now I can go back into my toolpaths here. Let me turn that model back on. Now I can go back into the toolpaths here, and let me turn all the plugs on here. Okay, so this is how I made those. I made those 3 plugs, right? I can go back into the toolpaths manager, and now I can drive my OptiRest roughing operation with model geometry. I can create a third, second category under machining geometry, and that is protect the pockets. That's what I called it. And I'm selecting those plugs, right? And I'm leaving the same amount of stock on there. So now that toolpath is no longer going into those pockets. If I turn that stock model on, see, it's not running down inside those pockets. It's completely protected from there. So now I want to come back with a different strategy, maybe so I got a question that says double click to it's double click to select the feature, isn't it? Triple is full for full solid selection. That's true, except for inside the function, that model prep function that I was in. And you can see that in the drop down. If I could be wrong here, let's launch that real quick. So double click to select a feature. I misspoke there. You are correct. Thanks for the correction. That's why it unselected again. All right, so now I've got a stock model. I can come in, you see this as it is, and if I were to take and run a rest operation off this, it might come in and try to get material here, drop into this pocket, might go into this pocket. I only want to do these 3 areas. So instead, I come in and create a stock model, and as my selections, I select these 3 solid plugs. Okay. Now when I select those 3 solid plugs, my stock model, let's shut off these plugs here. My stock model is going to look like this, right? There's just 3 chunks of stock there. Let me shut off that model to be clear, right? Those are the 3 plugs that the toolpath can now see as stock. Okay, jump back in here, shut that stock model off. So now I go into my OptiRest operation, and as stock, I select one other operation and I grab that stock model. Okay, what that's going to result in is a toolpath that's only going to hit those areas that I specified. It's gouge checked and aware of the entire part. Okay, so it's never going to hit any of the other functions. It just any of the other features. It just knows that those areas are what I want to machine, and it's trimming out everything else out of that toolpath. Okay, so let's move on from there. If anybody has any questions on that, feel free to hit me up. So now I want to talk about doing this. Okay, got another question. When using stock models, why does it look transparent in the machining areas when verifying? So the reason it looked transparent is because I have glass turned on in that machining area. Or I have that in my view, I have glass turned on. And then the other question is, yeah, I don't quite understand that. I'll try and circle back to that one. So let's move on to using stock models for finishing, because this is something that's often overlooked. And actually the next webinar next week, done by Dave, our mill product owner, is going to exclusively cover stock models with finishing. But I just want to show you some of the power that we have there. So jumping back into Mastercam here, let's shut this off. Let's jump back into here. And I just want to show you, so typical waterline toolpath, I've selected the surfaces coming all the way around the outside of this part. You can see the break in the surfaces. We're doing this whole edge. Now I can do something very similar to what I did with that roughing operation. Is I can come in and say, all right, I want to create a chunk of material to trim that water line out, right? And maybe I just want to, maybe I only am worried about this corner, okay? So let's go into the top plane. I'll set my the 2D to here, and let's go solids. We'll create a cylinder somewhere here. Okay, and this is just something quick to show you how this would work. So I can say, all right, I want a chunk of material there. That's what I want to trim my tool path to. Okay, so I can go into a stock model now. This is left over from before, but I can say, all right, I want to pick that chunk of material. Let me create a stock model from scratch here. Toolpath, stock model. Let's go to that chunk of material. All right. I'm going to set my additional offset to 0 here first. Source operations. I don't want any source operations here. Okay. What that's going to do is create a chunk of material right on that corner here. So now I can say, all right, well, let's copy this waterline toolpath down, and let's, in our stock tab, finishing operations have stock tabs as well. I can say, okay, let's reference that old stock model. Okay, and that is operation number 14. So I'll scroll down here, op 14. Okay, now I regen this water line, and it's respecting only that corner area. Now, say we want this to blend out further, right? Well, very simply, I can just re-go into that stock model, relaunch that stock model, and say, I want it to extend out 10 millimeters in all directions. What I'm doing is blowing up that stock model. This is referencing that stock model, a quick regen, and now that toolpath is extended out. Again, gouge checked against everything because it's smart about where that is, right? And now it's seeing just stock in those areas, so that's what it's going to attack. There's a question about retracts. The retracts are not going to be controlled by the stock. The stock in this case is just used for rest machining and for the toolpath to see where there's material to operate off of. The retracts are going to be controlled in the same conventional way that they would. This isn't really going to have an effect on retracts. Okay. So we're just trimming out 3-axis finishing operations using some manually drawn stock models. Just using solids extrude, and then you create that stock model, and then you hook up the rest machining in those 3D HST toolpaths to see that stock and trim out the toolpath. So next I want to show you, this is kind of your worst nightmare. You're sitting at the machine, right? And you miss something. Whoops, that wasn't supposed to happen, right? If you had looked at Verify, if you had looked at simulation, you would have seen it, but you didn't. Now you've got a gouge in your part. Or you've got a mold that's worn out. They go in, do some weld repair on it to fix it. But either way, I got to send this out now. I've either got to scrap the part, start over, or if it's a high value enough part and specs allow it, I could actually weld on the part and then do some repair on it. So that's the scenario we're going to look at here, right? So what can we do to fix that issue, right? And let's say that when we initially machined this part, it was done with a 5-axis parallel operation. So this was done on the surface, nothing too crazy, but it's just a simple 5-axis surfacing operation that comes across the part, right? We can now, once we get that weld repaired, we're going to leave a big weld bead on this part where that gouge was. We could now trim out this tool path to show only that area, right? So I'd go in, just draw a quick little boundary about where that is. Now we're going to use that surface to associate the stock model to. I can go back into surfaces, flat boundary, select that boundary. There we go. That gives me a surface there, right? And now we can use that trick with the additional offset to create a stock model. I'll go back into the toolpaths, create a stock model there. My model, I can pick a surface for a stock model. And now I can say, all right, how big do I want to make that? I don't know. Let's give it 5 millimeters of additional offset and see what that looks like. Right? That's going to give me a big wad of material there, kind of representing that weld bead that we're going to have to leave on the part. Obviously, it's bigger than it would be, but that's okay. We want that to run over and blend out that component. The cool thing here is, drop this up here. Let's drop this down here. So the neat thing here is that this parallel operation, I can use it to do the remachining. I'm just going to copy that below, go into my parameters, and turn on stock, reference that stock model, and regen. What you're going to see is that cut pattern that you're seeing exactly lines up with this one. So if I turn both of these on, you'll see that cut pattern is identical. So if I had tooling marks in the part still, I could go in and recreate that only in a small area. All right. So that's going to give me a nice trimmed out section of toolpath that's only operating on the area. Oh, I backplotted both of them. That's only operating on the area that I'm concerned about. Okay. And now if I made, because I have such an overlap there, that's why I'm getting that larger toolpath, which, like I said, is good because it's going to blend out the part. So we can look at what that would look like, in Machine Sim, right? So we can see how this toolpath is going to act on that specific area of the part. Now, one thing I'd want to do here is I don't know how much material is on there, and if that material is too thick, too aggressive of a cut for that tool, well, I can also use this for roughing. I can go in and run a couple steps on there. So I can say, all right, I want to turn on some depth cuts. I'm going to run 2 passes at 1.5 millimeters each. And that's going to offset right up to that area. It's also going to trim it out with the stock. It's not going to run passes that aren't in contact with that stock model, right? So it's a really effective way to really laser focus toolpath into a certain area of the part to address a certain need there, right? So we can look at that. I actually have a video of that running on the machine. Oh, wrong video. Hold on. That's the gouge. And then we can. So we used the 5-axis toolpath. We trimmed using the stock model. We built that surface representing a concerning area, made the stock model, added the additional offset, and then turned on the stock inside the toolpath. And then the end result is something that works pretty well, right? We're taking that weld bead in 2 passes. And blending it right in, right? So what I'd really like you guys to check out is on one of our signature part videos on our YouTube channel, this Remachining Made Easy with Mastercam. It's actually our second most popular signature part video. So head over to YouTube and check that one out, because that goes into this like in real depth with the 5-axis side. It kind of ignores all the 3-axis stuff we talked about to set up the situation. But it does do a little bit more there. So I would encourage you to check that out. And I'm going to take this link and I'm going to post it in the chat so you guys can head over and watch that YouTube video. And then I still got a few questions that I haven't answered here, so we're gonna go through those in a second. Let me throw this in the chat for you guys. Okay, you should have that YouTube link now if you want to check out that video. I've got a comment on here that says, "This is cool. Is using containment going to give the same result? It would match passes from previous full face pass." Yes, containment does work. The thing that I really like about using something like the stock model is it's almost a volumetric. It's really no different than a containment, but containments are limited to 2D, right? You're drawing something in a plane in a 2D perspective. In this exact case, yeah, it'll probably work pretty good, but it's not going to be as intelligent as something like a stock model is, especially when it comes to 3D areas. Like when we looked at that water line, and you don't have that adjustment. If you go in and draw a 2D containment to an area, it's, you got to go in and offset it or try and control it. This is very simple to use with using that additional offset on the stock model to change how your containment works. And it's all associative. So if I move that solid around, like when we did that water line example, I can get the tool path to cut different areas. There's a question about how to reduce retracts in rest roughing. Okay, so let's jump back into Mastercam here really quickly. If you're talking about a typical rest rough operation with an Opti, something that I'll use a lot to reduce the retraction, height on the part is under linking. And instead of doing a full vertical retract, I'll do either a minimum vertical retract or a minimum distance. Minimum distance, what I'd highly recommend is using a feed move. You don't know how well, maybe you do, but if you don't know how your machine is going to react to dog leg moves, and what I mean by a dog leg, the X and Y lag, it's a drag race for the X and Y to get to that position first. And we can't accurately backplot that in Mastercam because every machine does it differently. So by outputting a feed move, it leaves those retracts synced, and it will come over the part just as as tightly as you specify. Basically, I'm saying a 4mm clearance against the part. It's going to hug that part a lot better. All right, and I'm also reading that question. I may have misunderstood that question, asking how to reduce retractions in rest roughing. And that may be, instead of trying to keep that retract distance down, you may be asking about how to keep the tool from jumping around as much, from hitting little areas that aren't important. And one of the biggest, I saw another question on this anyway, so this is good. It'll cover those too. One of the biggest things you can do is turn on ignore small cusps. What this is going to do is keep your tool from going in and hitting a little area that you're going to clean up in a semi-finish anyway, or a finishing operation that isn't really important. You will need a tool that's either a bull or a ball to use this functionality. It doesn't support flat end mills, but a lot of times what I'll do is I'll go in, and even on my flat end mill for roughing, I'll fake in a 5 thou rad on the bottom, define it as a bull, and I'm leaving 50 thousandths on the part anyway, or 20 thousandths on the part anyway. That 5 thousandths isn't going to matter. And then that allows me to put in 5 thousandths, or, in this case, I can put, 0.1 millimeters in there. Or you can even get aggressive. If you're working on aluminum and you're not really concerned with leaving a little extra stock on to go take care of in a semi-finish, I mean, you could tell it to leave. If you got a 1 millimeter or a 0.5 millimeter radius on that tool, you could tell it to leave a 0.5 millimeter. And that's just meaning that you're accepting the fact that there might be a 0.5 millimeter more stock on there than what you specified. But you will literally see this affect your cycle time and your retract times. All right. With that, I think I'm going to call it. Thanks, guys.